Okay, so we have started recording our session right now. And today we have two things to discuss and to do some exercises together. One of them is t-distribution. Until now we talked about two things, right? Normal distribution, normally, like in our sampling right now. And we said we also have standard normal distribution, right? Standard normal. So normal distribution was something like normal distribution. Let's say 100 was our mean and 16 was our, or 16 square was our variance, right? This was the normal distribution. But standard normal distribution was the mean was 0 and standard deviation or the variance is 1. These are the two things that we have covered so far in terms of normal distributions, okay? And we will be talking about two distributions today, which are like t distribution and f distribution. And we will use this t distribution, f distribution in the coming chapter, which is kind of estimation. We will be estimating the variance. We will be estimating the proportion in a certain population. We will be estimating or predicting the mean of that population with a certain significance level. Okay, so this is something coming up. So on Thursday, after the quiz that we have, we will have these kind of we will call them point estimation. Okay, we will call point estimation, and then we will be talking about interval estimation on Thursday. Okay. So let us get started with t-distribution. If you remember from central limit theorem, we were talking about we have the let's say the means of the samples, right? The mean of the samples were converging to the mean of the real population if we increase the number of samples in a certain sampling random sampling period. So in those cases, if you remember, we were always talking about the distribution like that, and we have this distribution, and here we had the mu, right? So the distribution of the sample mean was something like a normal distribution whose mean was converging to the mean of the real population. This is kind of the logic behind the central limit theorem. If you remember, we talked about two formulations. We said like there was a z variable, and we said our x bar minus mu divided by sigma divided by root n. Do you remember this z variable stuff? We have the sample mean. From the sample mean, we were finding the z value. From the z value, we were finding the probability, right? This is how we go. From the sample, we find the sample mean. From the sample mean, we find the z value using the population mean and population standard deviation. And because we are doing the sampling, as the central limit theorem says, the standard error of the mean, that means the variance of the mean, changes or decreases with divided by n, the number of samples, right? Number of samples in our random sampling. So from this z, we were finding the probability. Do you remember all these stuff? Let me show you here. We talked about all these before, and this is critical that do you remember these two things? This was about the central limit theorem. This was the z that we are talking about, and we know that there is a variance, finite variance in our random, let's say, population. You know, these are the parameters from our population, and we are trying to find out the z parameter from the mean of the random sample of size n. Okay, if we increase the number of n, if we increase the number of samples, then what happens? Then it becomes more close to approximately normal, we call it. Okay, approximately normal. Then the distribution of the mean, the distribution of the sample mean becomes close to normal distribution. Okay, that was the idea, and which is something that I'm talking about in the last almost 2 weeks. Everybody is okay with that? You are with me and you understand what's going on here, arkadaşlar? You are with me? Yes? Okay, let's move on. Why do we need T distribution, F distribution, all this stuff? This is a kind of general explanation of the Z distribution or standard normal distribution. But here we will be talking about T distribution. And what is the relationship between T distribution and Z distribution? What was the, again, what was the assumption here? We know the population mean, and we know the population standard deviation, right? We know these. These are given to me. How do I know them? Because I'm an experienced engineer, and I know from my production line, from my data, from my observations, I know what the mean should be and what the standard deviation should be. Okay, I know them from my previous experience. But in T distribution, this may not be the case, right? So if you remember, we know the mu and sigma normally. If it is given, if I know it beforehand, then I can immediately use the Z distribution, right? But if I don't know the standard deviation of my population, if I don't know it, what happens? This is where the T distribution comes into play, okay? I don't know the sigma, I don't know the variance of my population. The mean of my population is given to me, okay? This is given. Let me have my pen again. This is given, this is already given. I know it from my previous experience, but this is not what I know. I don't know the sigma or the variance or the standard deviation of my population. So what happens? I will try to obtain this from where? Where can I get the sigma value? How can I get the sigma value of my distribution? I can get it from my samples, right? Samples, as we have done in the sample variance situation, right? This is coming from the samples. The standard, let's say the mean, sample means are coming from the samples. If this is not given, I can also find it from the samples, right? So now in this part, in the T distribution, I will be finding the samples, sample mean, and sample standard deviation, and come up with this kind of a T variable, arkadaşlar. Okay? Now before we had Z was the random variable, standard normal distribution random variable. This is random variable from the standard normal distribution. Here, this is the T distribution in which I don't know the sample distribution, the standard deviation of the distribution, so that I will use the variance or the standard deviation of my sample. This is coming from my sample, this is coming from my sample, and I will find out my T value using only by knowing the mu value from my population. This is coming from the population, this is coming from the sample, this is coming from the sample, and this is the sample size, okay? So this is how we will go actually. So in Z, we know mu and sigma. In T, we don't know mu and we don't know sigma. We know mu, but we don't know sigma, okay? So we have to estimate it from the sample itself. So this is how we will go from now on. And I want you to remember this in the coming slides. And this is like very similar to Z. You see the difference between Z and T, arkadaşlar? You see the difference between Z and T? This is approximately normal, right? Approximately normal, standard normal distribution. And this is also like normal distribution, but we don't know the sigma of my population, okay? So let me go further. Population variance, sample variance. Yes, we don't know the population variance here. We estimate it from the sample. Okay, that's the only difference. That's the trick over here. Şimdi, this is also critical. If my sample size is small, arkadaşlar, if you remember from the MATLAB exercises we had, if you run the code that I shared with you before, if the number of samples is small, okay, the S square values will fluctuate considerably from sample to sample. So when I have this population and I take one sample of size n, I take another sample of size n, another sample of size n, and from this sample size of n, I will obtain the X bar and sample standard deviation or sample variance. I will obtain X bar. Let's say this is 1, this is 1, this is 2, this is 2. I will obtain another size n, and then I will get these, right? So I can do it many times. What if my n, the sample size is small, then this value will fluctuate. Will fluctuate means change considerably, change in a very high amount, okay? So if size n is small, then my standard deviation or the variance will change dramatically from sample to sample. That's why if then we will talk about this T distribution with respect to n as we go further, okay? If the sample size is large, if I obtain these n's, like let us say greater than 30, let's say 40, 50, 80, 100, then these sample variances will not change considerably, okay? So what we will say then it's gonna be T distribution will be very close to the standard normal distribution. Burayı anladık mı arkadaşlar? If n is greater than 30, then T distribution will converge to the Z distribution. If n is less than 30, let's say 20, 15 or something like that, then we should go and deal with the T distribution, this formulation then, okay? So that's the main idea. So if we are dealing with n less than 30 and the distribution is normal or approximately normal, we can use T distribution in our examples, okay? Yes, Bilal asks that, do we use T distribution for small sample sizes? Yes, that's true. If my n is small, I use T distribution. If my n is large, okay, then I go to the Z distribution, okay? And then Z distribution, instead of this, I will have my sigma, okay? So we will have some examples and then we will know it better, hopefully, okay? Let's go further. Here is the explanation, but we have to be careful again in this case. We have the, what is this? What is this, arkadaşlar? X bar. What is X bar? What is X bar? mean of the sample mean. Very nice. What is this? This is the sample variance. We talked about that. On Thursday, I will explain to you why we use 1 over n minus 1. Why not 1 over n? Okay, we will not say 1 over n, but we will use 1 over n minus 1. I will explain that on Thursday. Okay, so this is the sample variance, and this is the sample mean. So if this is the case, and if I have n's less than 30, then I will use this random variable t, and I will be talking about the t distribution from now on. But I have to be careful about the degrees of freedom again. If you remember, we talked about degrees of freedom in chi-square distribution, variance distributions. Do you remember the chi-square distribution? S squared times n minus 1 divided by sigma squared. If you remember, this was the chi-squared value, chi-squared, and this was distributed. This was a kind of chi-squared random variable, and it has a distribution something like that, right? With changes with respect to the sample size. So degrees of freedom is highly related to the sample size. If you remember, degrees of freedom is equal to what? Degrees of freedom is equal to n minus 1, right? Degrees of freedom is equal to n minus 1. So I observe 20 data. The degrees of freedom is going to be 19 if n is 20, right? So in t distribution, I have a couple of things that are important. What are they? I have to be obtaining my sample variance from my data, from my observations. I have to obtain this from my data, from my observations. This is going to be given due to some previous experience. I know it. I know how many samples I get from each observation. And then I have to be careful about degrees of freedom in my t distribution, okay? If you look at these graphs here, you will find the distribution of t changes with respect to the degrees of freedom. Can you see that, arkadaşlar? As I increase degrees of freedom, like that, okay, then it becomes more close to a standard normal distribution, okay? If my observation goes up or V goes up, what happens? My t distribution will be converging to Z. Then I will be using the Z table, not the T table, okay? But if my degrees of freedom is less than 30, let's say 20, then I will be looking at T table whose V will be like 19, okay? N is 20, so my nu or V will be 19 if N is less than 30, okay? So if I go up in terms of observations, if I observe more samples, then my distribution will be close to standard normal. Then I don't need to deal with T table. Then I can look at the Z table and obtain all the values, probabilities from the Z table. If you remember, what was the Z table like? We have this, right? And then we have 0 here. We have a value here, okay, Z1. And then we were talking like probability of Z1 or our random variable greater than something, okay? Z greater than Z1. So this is what we were doing previously. So now what are we going to do? We will have a distribution with respect to changing with respect to n, okay? If I change the V value, my distribution will be changing. You see, it becomes much more like a Gaussian bell curve shape. If V is small, then it is much more let's say the tails, we call these things as tails, okay? Tails, kuyruklar. These tails, the probabilities will be higher, okay? Burayı anladık mı acaba? Normally, this is the standard normal distribution, but in Z transform, T distribution, it becomes something like that, okay? So the tails will have more probabilities here. Okay, the probability after a certain point will increase if our degrees of freedom is small. Evet arkadaşlar, what do you understand? I want you to write to me right now, in a private manner, what is the main difference between T distribution and standard normal distribution? What is the difference between T random variable and Z random variable? This is my question. Okay, let me write again. The difference between T and Z. What are the differences between T and Z? If I would like to write the Z here, X bar minus mu divided by sigma root N. Evet Muratcan, thank you. Any other differences? Any other differences? Evet Bilal, thank you very much. Nice job. Sample size is critical. Very nice Ziya. Onur Metin, thank you very much. Very nice. Muratcan. The tails have greater probability with respect to Z. If I have Z, the tails will have less probability. If I have T, the tails will have more probability. If I have the sample size less than 30, right? Okay. Okay arkadaşlar, thank you very much. I got responses from at least 10 people, more than 10 people. Thank you very much for your nice feedback. I understand that you got the main point, you got the main message. Şimdi arkadaşlar, what do you see here? This is a little bit critical also. Let me explain to you that part. Now, do you remember that we had this X bar, and from X bar we were having Z, and from Z we were having something around 0, right? If you remember that was the case, then we were finding the area under the curve for a certain value. Here we have a similar thing. From X bar and variance, we will have such a distribution. We will have such a distribution, again around 0, right? Because it is now close to the mean, we are still talking about the mean distribution, okay? Sample distribution of the mean. Sample mean distribution, actually. So we will have this T alpha values, and this alpha will be, the area under the curve will be critical, okay? We will be talking about these in a minute. Okay, these are called tails. Tails. This is right tail, sağ kuyruk. This is left tail, okay? Left tail. And you will hear this a lot also, two tail. Okay, we will also be talking about two tail or two-tailed, okay? Two-tailed analysis or something like that. Tails, two tails. We will be talking about this alpha in a minute, which is something like, we call that critical value, okay? Critical value, okay? And we said that it is significance level. We will talk about that in more detail as we go further. But this is critical arkadaşlar. 95% of the values of a T distribution with a certain degrees of freedom lie between this T, which is 0.025 to T 0.025, okay? Minus, this is minus t 0.025, this will be plus 0.025. If the values are between these two values, the probability of obtaining a value between this and this is gonna be 95%. Okay, man. For a t distribution, if the t value between 0.025 minus 0.025, t of 0.025 to plus t of 0.025, we will have 95% of the time we will have our t value here, okay? Exactly 95% of the values are between these two critical points, okay? This is something that we will use very frequently in these examples, okay? Let me show you the t table. Everybody got the idea, arkadaşlar, here? Yes, degrees. We will be talking about a couple of things in t table, okay? This is the t distribution we talked about before, okay? So this is the t distribution. We will have the alpha value, and we will have the t alpha value, okay? So everything will be dependent on the new value or v value. What was v value? Degrees of freedom. So these are the degrees of freedom which will come from the sample size. This is the alpha values that I will be determining beforehand, okay? For example, 0.025, which I talked in a minute, 0.025. This will be what? Alpha is 0.025. What does it mean, arkadaşlar? 0.025. What does it mean? Alpha is 0.025. The area under this kind of bell curve shape, approximately normal shape, the area here is 0.025. Okay? So if a certain degrees of freedom, if the degrees of freedom is 10, okay? What happens? What is the t alpha value? I come here, and find my t alpha value. So this will be my critical value, okay? This is the area, and this will be my critical value. Why is it critical value? Because I will be comparing my t from my sample and saying that if my t is greater than this or less than this, I will decide on something, okay? So this is a kind of threshold value which will help me to base my decision on, okay? Alpha is my area under the curve, okay? And it changes, you see. There are some critical values here. And everything depends on the degrees of freedom, as you see here. If it is 10, this is something like that, okay? For example, if the t value is 0.005 and my observation is 10, then degrees of freedom will be 9, and I will find this value as my t alpha value. Nasıl gidiyoruz arkadaşlar? I have my alpha value from my question, or which I will decide, okay? Given, it will be given to me, or I will decide, okay? I will decide on that value, okay? This alpha value will be something that I will be deciding. What is this 9? Where is this coming from? Where is this degrees of freedom coming from? From the sample, right? From the sample size. From the sample size, I will be finding v equals n-1. Then I will find my t alpha value. Okay? This is gonna be my t alpha value, critical value. Then I will, from my sample, random samples of n samples, okay, I will find one t value. Then I will compare this t, whether it is less than t alpha or not, okay? This is how we will go. Then, as we said, if it is something here, 95% of the case, t should be here. Okay? For example, for 9, degrees of freedom 9, this will be 1.833. This will be minus 1.833. And 95% of the time, my t value should be coming from this interval. If it is not from this interval, then I will say this is something uncommon. This is unlikely that this is in that interval. Okay, this is something that we will talk on Thursday. But this is how we will go. Now I want you to grab this idea of comparing my t value, which I find from my sample, from my observations, and this is something that I obtain from the given values. Okay, this is something that I obtain from the given values, which are like alpha, or let's say the number of samples. Then I will find out. I will perform some kind of statistics. Zia asks one question. Let me try to answer. Hocam, what do we consider the area behind under the curve? What's the logic behind it? So, if you remember from the Z, what does it mean? 0.025. 5% of the case. Let's say I am generating random numbers, arkadaşlar. Okay, I'm generating random numbers. 95% of the time, it will be less than this value. Okay, if the value that I would obtain something here in this part will be 5% chance. So only 5% of the values will be in that area. It means something like that. If you remember the probability distribution, how was the probability of something we were obtaining? Let's say from 1.833 to infinity, our f of x dx. Do you remember that? The probability of something would be the area under the curve for the PDF function, right? This is our PDF, t distribution. This is my PDF. And from this PDF, I can find out the probabilities. The area under the curve will give me the probabilities. The total area between minus infinity to plus infinity, what was it? This f of x is this distribution. What was it, arkadaşlar? The total probability should be equal to 1, right? So if this is 0.05, it means only 5% of the cases, the values in this distribution will come above this value. Anlıyor muyuz burayı? Arkadaşlar, do you follow what I'm saying? 5% of the time, this will be above this value. And okay, again, 5% of the time, it will be less than this value. So what is the probability of obtaining something here between these two values, arkadaşlar? What's the probability between obtaining a value here? Very nice, 90%, right? 5% here, 5% here. So the remaining 90% of the chances of obtaining a value in t distribution between this value and this value will be equal to 90%. Or the probability of obtaining a value greater than 1.833 is 5%. The probability of obtaining a value less than 1.833 minus 1.833 is again 5%. You got the point, arkadaşlar? Yes? You understand the topic? Yes, arkadaşlar, I heard 2 yeses only. Any other yeses? Any other yes? Yes. Yes, I can see that at least 5 or more people have gotten the idea. Okay, let me go to the next example. Bakın arkadaşlar, here we had until 15 and for different alpha values. Now I have this, right? For different v values, we up to 30. You see, different alpha values. If my, bakın şimdi, again with 0.05, and I have more samples. Here I had 10 samples, right? I had 10 samples and degrees of freedom was 9. Here, let's say I have 26 samples. What is changing? Previously, I found the probability or the critical value being 1.833, right? This was 833. For what? My n was 9. So the sample size was 9. What was my T alpha value? 1.833. For which alpha? Alpha is equal to 0.05. Okay. So let's go to the next one. Let's say I now have n is equal to 26. I have 26 samples. And I still have 0.05 alpha. What is my T alpha value arkadaşlar? What is my T alpha? What is my T alpha? This, right? Again, 0.05. And 26 is my sample size, so I have to go to 25. And here is my T alpha value. What is 1.708? What does that mean? Before it was 1.833. Now it is less. What does it mean? What does it mean arkadaşlar? It becomes close to Z distribution. So it was here. Now it is a little bit more like that. Critical values. Ahmet Furkan, critical value decreases while n increases because tails getting smaller. Very nice, Ahmet Furkan. Thank you very much. Yes, the tail becomes not so big this time, but it will be smaller like that, right? The area under this curve. Let me draw it again. Now this is T, 1.708. The area under this curve is still 0.05, right? Because the sample is more close to 30 and it becomes with less tails, right? Less tails. If my sample size is low, the tails are greater. The area under the tails are greater. If I have a larger sample size, then it becomes closer to n, closer to normal distribution. So it was something like that before. Now it is something like that. So a smaller T value will give me the same alpha value. Okay. This is something that I would like to describe to you very critically. I have 5 minutes more and I will be talking about one example. Arkadaşlar, do you remember this example of 500 grams of raw material? To check this claim, he samples 25 batches each month, okay? And if the computed T value falls between this and this, what does it mean? Minus T 0.05 and T 0.05, what does it mean arkadaşlar? What does it mean? 90%, right? Now I would like to obtain some samples and I'm trying to find out if the T value is in this let's say interval. Then if it is in that interval, that means 90% chances that I will have a value between these two values. Okay, let me explain this again. If it is like minus 0.05 to plus 0.05, then I am talking about 90% chances, okay? 90% of the time, T should be in this interval. If it is not in this interval, it is a rare situation, okay? It means it's a rare situation. It is not so likely. It is not so likely to have this situation, okay? So how do I start my how do I start my solution? N is 25, right? And mu is what? Mu is what arkadaşlar? Mu 500 grams, right? 500 grams per milliliter of raw material. So it is given to me. N is my sample size. And what does it find? X bar, from these 25 samples, I find X bar being equal to 518. And again, from my sample, I find standard deviation as 40. Okay. So given these, what should I say? What conclusion should he draw from a sample that has a mean 518 and standard deviation, sample standard deviation 40? So how will I continue? T is equal to 518 minus 500 divided by what? Divided by 8. Neden? 40 divided by root 25, right? N is here. Sample variance is this. And it will be equal to 2.28, right? 18 divided by 8, which is 2.25. So what is next, arkadaşlar? What is next? I should be finding the critical value, right? What is the T 0.05? What is this? I go to the previous example. Here 24, 0.01. This is what? 1.711, right? 1.711. From the table, I try to find the critical value. What is it? We find this T value. We find our T value as 225. And for 25 batches, 25 samples, I find my alpha as, or T alpha as 1.7. Now I will compare these two. What does this comparison tell me? Yes, this value is not between 1.711 and minus 1.711. So it is not something that I expect, okay? If my critical thing is here, then I cannot say this observation is like 90% of the time it should come here from this interval. This is what I was saying, right? This is something that I said 90% of the time it should come from this interval, but it is not coming from this interval. So I say it is something that I don't like because it is not fitting to my assumption. Okay, this is what I say. Evet arkadaşlar, I hope this has been understood. In the last couple of minutes, do you have any classes afterwards, arkadaşlar? Yes, this is no classes. Yes, some of you have some classes. I will continue, and then if you want to stay, please stay. If you don't, just leave and watch the video afterwards, okay? Because I would like to talk about F distribution, and then on Thursday I will be giving you questions in the quiz for the whole 8th chapter, okay, which we have covered so far. So the quiz will be about 8th chapter, random sampling, T distribution, Z distribution, and sample variance, those kind of things. And finally, I will be talking about F distribution, okay? So Enes is asking me, what do you recommend, Hocam? The exercise we did in recitation hours in previous weeks, the assignment. because in my lab study plan, it does not have exercises for most sections under chapter 8. You should go and check the book's exercises, okay? The book exercises will be similar to what we have in the assignments, in the quiz, okay? So please check the book's exercises. If you are able to solve them on your own, then you will be able to solve the quiz questions, hopefully, okay? So please get ready at 1:10 on Thursday. You will have a quiz at 1:10, just as we are doing in our regular time, or 1:15. It will be half an hour quiz. And then after this half an hour, we will continue after a 5 or 10 minute break. We will continue with our own schedule, talking about some interval estimation, point estimation kind of stuff, okay? So finally, arkadaşlar, thank you very much for the ones who attended today. And I will be talking about maybe 10 minutes more and then finish, okay? Arkadaşlar, everybody is okay? If you are not here, no problem. I will, in any case, I will record this for myself, for the other people. If you join me, then I would be happy. Şimdi arkadaşlar, we were talking about t-distribution. What was the case for t-distribution? We were trying to find out the mean, right? Sample mean, because now t is showing us, t is a random variable, which is related to the sample variance, sample mean, and the sample variance, right? This is something equal, related to this t random variable, and t distribution is somewhat related to the mean and the variance. What did we compare here, arkadaşlar? What was the thing that we compared in this example? We compared the sample mean. We compared the sample mean here, the sample mean, with the given population mean. This is what we have done in t distribution, right? We are comparing our sample mean with the given population mean and saying that if the sample mean is something like close to the actual mean, right? This is what we are trying to say. Is my sample mean close enough? Can I say it confidently that, yes, this is coming from this population, okay? So this is my population mean, this is my sample mean, and I'm trying to find out if my population mean is somewhat close to the sample mean, okay? And I will compare these two. This is what I've done before in t distribution. Now here in f distribution, I will be comparing two observations. Two observations, okay? Now, two data, two growth media, two coating materials, two resistance types, two sensor data, okay? I have two things right now. And I will be doing in F distribution. Now, I'm not going to be comparing population means. I'm not going to be comparing population means this time. If you remember, we did that before. We are not going to be comparing population means. If you remember previously in our exercise, we were like comparing mu1 and mu2. Do you remember this, arkadaşlar? From previous exercises, we were doing that mu1 minus mu2 is going to be my new distribution. The difference between these two means. This is what we have done before. Now, I'm not going to be discussing if these two means are equal, okay, or very close to each other. Now, I will be comparing the variability of, the equality of the variability. Before we talked about the means equality. Now we will be talking about the variances equality, okay? Arkadaşlar, in coming weeks, we will be saying, is the variance of this population equal to the variance of this population? if I obtain this sample and this sample, are their variances equal to each other? Which we did before. We were obtaining means of one population, one sample, another sample, and we were comparing if these two samples are equal to each other. This is what I have done before. Now I will be talking about comparing sample variances, okay? I will have S1 and S2, and I will compare these two, if they are equal or not, okay? If they are similar to each other or not. This is what F distribution is going to be about. And if we are talking about two or more samples, then we will be applying F distribution, or F test, we will call that in coming weeks, okay? So if you remember from your previous examples, previous exercise or previous readings that you have done so far, F statistic is something like that, right? So F is my new random variable. F is my random variable. Arkadaşlar nasıldı? T is my random variable. It is something like this, right? This is my random variable, and it depends on this, and the population mean and the sample size. Now, my F distribution or F random variable, okay? These are what? These are the sample variances of one sample. This is the sample variance of the other sample, right? Sample variance of one and sample variance of the other one, okay? I don't care if you remember this or not. Nobody memorizes this kind of thing. But what is saying here, T distribution had this kind of a distribution, and it was changing with respect to the V values, right? The degrees of freedom. Here we will have also a distribution which will be affected from the degrees of freedom of each sample, okay? This is the degrees of freedom of the first sample. This is the degrees of freedom of the second sample, okay? We have this sample, variance and degrees of freedom of the first sample, the other sample variance and other samples degrees of freedom, okay? So we have these, arkadaşlar, if you remember, the variances had chi-square distribution. Do you remember that? Sample variance had chi-square distribution. And if I have one sample distribution, and this is the variance of the first sample, this is the degrees of freedom of the first sample, and this is the standard deviation or the variance of the first sample, okay? So what is the purpose again? I will be comparing these two right now. I will be comparing the variances, but I cannot compare the variances directly. What should I do first? I have to go from my sample variance to chi-square distribution, okay? Because sample variance is not a random variable on its own, but it has to be converted to the chi-square distribution, okay? I now have two random variables with different sample sizes, with different variances. Then I will be comparing chi-square 1, chi-1 squared, and chi-2 squared, and then tell that if these two variances are close to each other or similar to each other or equal to each other, okay? So this is also called analysis of variance. Oldu mu arkadaşlar? You will hear this a lot, analysis of variance. So now we will be comparing the variances of, we will be comparing the variances in that sense. again, how do we start? From sample variance. From sample variance to chi-squared. For not only one this time, but two samples. Then, using some degrees of freedom, as we mentioned here, we will have again F distribution tables, okay? F distribution tables. And we will check those tables and then find out if our two variances, chi1 squared and chi2 squared are close to each other. Okay, this is what we are talking about right now. So, but what is critical about F distribution? In F distribution, we talk about the degrees of freedom all the time. Okay, again, just like T distribution, the F distribution changes, varies with respect to the degrees of freedom, okay? Of degrees of freedom of two samples this time. In T distribution varied with respect to the degrees of freedom of one sample, but this time in F distribution, because I'm comparing two samples, two observation sets, then I will be comparing the variances of these two samples. That's why I have to be taking the degrees of freedoms of both samples at the same time. What is V1? What is V1? N1 minus 1. Sample size of the first sample. What is this V2? N2 minus 1. Sample size of the second distribution. If it is 10 here, 30 here, I find this kind of a distribution. If it is 6 and 10, I find this kind of a distribution. Okay? So, for example, if I have this as my critical value, let's say F alpha, I will talk about that later, but what do you say, F alpha? If I give this F alpha, what's the area below blue and black curves? What is the area difference? The area under blue is here, right? The area under black is here. So if we talk about alpha, again, the area under the curve, for larger sample sizes, I will have a better estimation. Okay, if I increase the sample sizes, then I have better predictions, estimations. If my sample sizes are low, then the errors will increase. This is what we will be talking about. Okay. So for this degrees of freedom, for a certain degrees of freedom, Bilal asks, what if 2 degrees of freedom goes to infinity? Then you will see that Z distribution is it will be close to the Z distribution, normal distribution this time. Okay, if both are coming from very high values of samples, then we immediately describe this as like normal distributions, okay? Approximately normal distributions. So let me go further and explain to you again, this is my level of significance. This is the area of alpha. And if you look at some tables like that, this time, arkadaşlar, if you see here, F 0.05 for different degrees of freedom. This is the degrees of freedom of one sample. This is the degrees of freedom of the second sample, okay? So we always have this kind of a table because I have this as my sample 1 and this as my sample 2. And from these V1s and V2s, I find the F value, okay? F value is somewhere here. For example, it is 3 when one degrees of freedom is 6, the other's degrees of freedom is 12. My f of 0.05 will be 3. So this will be 3.00 for 12, or 6,12. Okay, 6 is my sample 1, 12 is my sample 2, and 3 will be my f. What is the alpha here then, arkadaşlar? If f alpha is 3, what is my alpha here? Very nice, Ibrahim, thank you. 0.05, because it is written here, right? 0.05. If my area under the curve is 0.05 and I check V1 and V2, find a value here like 3, then I go and put it here 3. After 3, in this distribution, obtaining a value greater than 3 is 5% probability. Okay? Probability of a value f greater than 3 is going to be equal to 0.05. Okay? This is what f distribution says. For another alpha value, as you can see here, this is my alpha value right now, right? If it is 0.01, again with same 12 and 9, what was 12 and 6, right? 12 and 6. Now this is my value. So what will I say? The probability of f being greater than 4.82 is equal to 0.01, 1%. The probability of obtaining f being greater than 4.82 is going to be 0.01. So for which values? 6, 12. Okay? These are my degrees of freedom. So Mohammed Muhsin asks something. Do sampling threshold we took 30 for the difference of T and Z change if population is very, very high? I mean, if population is thousands for a small data, but population can be 1 billion for another data, does this 30 value change in this situation? So if we are talking about very high amount of data, then we don't talk about these usually, okay? We talk about, we will assume that they are Gaussian distributions, and then as you see, let me show you here, arkadaşlar, one moment. Let me show you here. Can you see my screen right now? Can you see my screen? Yes. Let me see. Yes. Can you see this F distribution? You see, arkadaşlar, if this is infinity, and if this is infinity, okay, what is F here? F is 1, right? If this is very high, this is very high. After a certain point, it becomes very close to 1, okay? So what does it mean? If my sample sizes are very big, if the sample sizes are very big, then the probability of obtaining a value greater than 1 will be equal to 0.05, okay? The probability of obtaining a number, the variances, the F value. What is F value again? F value is this, right? F value is this. So the F value is going to be the ratios between two standard deviations or variances, so that we will be talking about these kind of things here, okay? N is great here, greater, so very big. Again, N is very big here. Then we say that the F value will be 1. So it will be something like 1 here, and the probability will be 0.05. So 90% of the case, it will be 0.05, okay? So let me explain to you on one example, and then I will finish here, okay? So if you remember, what are we talking about here? We are talking about the F here. How do I start everything? With calculating our F. How do I calculate my F? My standard deviations are given or I calculate them. Arkadaşlar, there are two cases. Either my samples are given like that, okay, the values are given like that, and I find the sample variances. Do you remember the sample variances? 1 minus n and total, right, like that, right? Xi minus x bar squared. So this was the sample variance. So from either it is given to me, or this thing is given directly, or it is given as standard deviation, or I calculate it from the data itself. So in this example, S1 and S2 are given to me. So standard deviations of my populations or my samples are given. Okay, so from this I find the square, which is the variance 1. And I know that there are 21 samples here. And here there is another sample, which is like 25 samples. And I find the variance as 118.81. What should I do next? What should I do next, arkadaşlar? What should I do next? I should find F, right? F will be 119.81 divided by 92.16, which is 1.23289. Okay, this is something like that. What is next? What is next? From F, from F, I find this thing, right? This is the chi-square distribution. And I find this as 1,289. What should I do next? I should go and check the F tables, N1 and N2, right? Let me go here. Yes, I divided S1 squared divided by S2 squared. Yes, so I am dividing these two. Divide. Let me explain. This is critical. Thank you very much, Bilal, for asking this. We should always be dividing the larger one by the smaller one. Okay, it should always give me a value large. Okay, so it has to be larger S value divided by smaller S value. Okay, this is a kind of hint that all the statisticians use. So we don't say 0.776. Instead, we say bigger one divided by smaller one. Okay, you got the point, arkadaşlar. This is critical. So I have my 1.2 here. Then I say from the tables 21 and 25, I go to the table in the book, A6. Let me go to the table here. Okay, let me come here. What was the values? 24 and 20. 24 and 20. So here 24, I don't find it here. Okay, 24 and 20 here. So it will be 2.03. So my F05 will be 2.03. What does it mean? For F, for 2.03 is my alpha value right now. Let me come back here. Let me come back here. And now I find from the table as 2.3. for degrees of freedom 24 and 20, right? So what do? I compare this with this one. Then I say these two are like this. What does it give me, arkadaşlar? Again, let me tell you that the critical value is 0.05. This is given in the question, let's assume, okay? So let me show you this here and finish. So I have my 2.03 and the area here is 0.05. So I find 1.2 here, 1.289, which is like 90%. I am 91% confident that this is what we will be putting out. I'm 95% confident that these two are coming from the same sample. So their variances are not significantly different from each other. This is what we say at the end, okay? So these variances are not significantly different from each other, okay? Why is that? Because I can say, but with 95% confidence, yani %95 eminlikle şunu söyleyebilirim ki bu iki varyans değeri aslında birbirinden çok farklı değil. One of them is 9.6, the other one is 10.9. I cannot just say, oh, they look similar. They are not similar. But I have to do this F test, okay? I have to perform this F test to be able to say that if they are significantly different from each other or not, okay? If my value is below this 2.3, then I can say this is 95% confident. I'm 95% confident that this is true. Okay, they are not significantly. Variances are not significant difference from each other. This is what my conclusion will be like. Evet, let me answer two questions from Ibrahim and Bilal. We compare two different samples from the same population. Yes, we are actually trying to say that if they're coming from the same population or not. Yani, we have this one population, okay? We have this population. We have another population, let's say, and then try to, or let me do this again. Let me draw it again here. I have one population like that. I have another population like this. Okay, these are two different populations, and but because their sample sizes are different, maybe they are coming from the same distribution, right? So I say I check this variances and then compare these variances so that if they are coming from the same distribution, normally the distribution was like that. We were obtaining samples from this distribution. We were drawing the sample mean and its variance, right? Sample mean and sample variance. So if they are coming from the same distribution, because their sizes are different, their shapes might be a little bit different, but they might be coming from the same distribution. So that's why we are trying to conclude that if these two variances are equal to each other and they are coming from the same distribution. Okay, so this is what we say. Bilal asks, what if hocam f is 2.3, which exact equals to the alpha value? This is not very common, but if this happens, we might say that it is not. Again, this is the question here. I have my F distribution. And I find my F as 2.03, and I found my F on this then it will be like somewhere here. Actually, I don't know the answer exactly, because if it is here, then I would say with 95% accuracy, confidence, this is they are similar to each other. They are not significant. So this is a kind of very tricky point, and I don't know the answer, Bilal, right now. It will be like 95% confident, but it is, hocam, in the book it says when it is lower, it says more than 95%. When it is lower, it is like here, you mean, right? When it is 95% confident. So when it is here, so if my F value is somewhere here, then this is 95% confident that they are not significantly different from each other. Maybe I should check the book and answer you later, okay? If you give me time on that, I would be more happy, because I don't want to direct you in a wrong direction. So this is what I know. If my F value is somewhere here, then it says they are significantly different from each other. This is what I would say. Yani let me stop recording here, and I will